Next, we have our in-house LLM model with there is APERTVS and Imanol will that is the development.
Yes, thank you so much. And it's a pleasure to be here and talk about APERTVS. I've been involved with the APERTVS initiative from the beginning, together with Antoine, who's also here, so do reach out. And Martin Yaki, who are two professors from EPFL. Martin can't join with us, can't be with us today. We have a bunch of engineers as well from the APERTVS team here. If you can quickly raise your hands, there are people working on post-training, SFT, reinforcement learning, pre-training aspects to it. So do find us and have a chat for more details, because we're not going to have the time to go into all of the details. And I'm going to try to be a bit quick here. So we all know, like, the progress in AI has been really relentless. Here we see sort of general capabilities over time, and we see that these models are really increasing to do more and more, and that they're also being adopted throughout the world in different places, all in also very different domains. And this comes with sort of unprecedented investments into AI infrastructure as well, mainly spearheaded by the big tech companies and their AI investments. And some of them may be more fragile than others. That's for others to decide, but there's clearly a benefit to this technology that is increasingly being adopted. But who is really building this? So this is roughly a map of like notable AI models that have been published worldwide in different countries. We can see that the representation is not as global and uniform as we might want it to have. And when we talk about models being developed, there's always roughly three categories that I want to quickly elaborate on. We have the closed models. These are the API providers, the big tech companies we're already familiar with. They usually don't share much about the progress they've had in developing the models. Since over 3 years, this progress has been hidden from the public as they've stopped publishing on the research that is affecting their leading products. And counter to this, we have these open weight models from a lot of Chinese companies as well. Some of them also present here today that you will hear from today. They share the model weights, but they are also somewhat secretive. They don't share too much information about the data they're trained on, and sometimes some technical details are also lacking. So it depends really. It's different from company to company. And then the third pillar is the ones that is really sort of dominated also by the public institutions, which are fully open models and fully open source models. Here with the Allen Institute of AI and SwissAI having some of the largest models, but also very powerful and notable research being done throughout Europe and Singapore, and also many other smaller efforts that are fully transparent when it comes to how the models have been developed, what data went into them, and how they've been also aligned. So the question is, like, are the current frontier models that everyone is using being developed in a way that is really for the better? And we argue that the way to move forward is really the fully open route and not the closed route. Because the way that they're currently developed is sort of undemocratic. There's very few private actors that are deciding behind closed doors how these models should behave, what sort of ideology goes into the development of these models. They're also often underrepresentative, especially when we talk about models that are more open weight. They might only focus on the English language, for example, which creates also a culture bias and is not as valuable to the world as it could be. Especially here in Europe, we also have a different regulatory environment, a different legal environment. So it's important to us as well that the models that we developed are in sync with these requirements, such as transparency, that is mandated by the European AI Act that many model developers refuse to provide. And so to summarize, we want to build our own models because it's a legal necessity, but also because we think that this is the foundational, this is the sort of technology of our time, and we want to be able to shape it according to our ideas and our culture. We want to have research and development autonomy, and we want these models to be deployed where we want. We want to have a certain independence of foreign actors. And lastly, and this is coming more from a scientific effort or scientific perspective, it's important that this also remains a scientific endeavor. Open weight models are great and very useful to build products, but due to the lack of transparency, they are inherently unscientific because they're not reproducible. And when we're talking about safety aspects, for example, it's difficult to do safety research, for example, if you don't know what sort of environments or data the model has been trained on. How do you recognize if a goal, an instrumental goal, has arisen out of the training or if it was actually planted in there through the data. And understanding these things is also important to make sure that these models are aligned as we continue the development. And this should be done by the greater public and not just by a few security researchers behind closed doors. So this is why we, within the Swiss AI initiative and the Swiss National AI Institute, came together and developed the APERTVS, which was a collaboration mainly between EPFL, ETH Zurich, and CSCS, but involves also people from other institutions. The first model we released was in September last year. This was an 8 billion model and a 70 billion model trained on 15 trillion tokens using up to 4,000 GPUs on ALPS. It's fully transparent. It is one of the first models that is compliant with the European AI Act, and it has over 1,000 languages in there that it has been trained on, while being conversational in quite a few. We have a lot of our own evaluations in our technical report, which has over 100 pages. But if you look at some evaluations from third parties here, for example, from the Leibniz Supercomputing Center, or on the right from a collaboration of researchers in the US, we can see that especially our 8B model actually belongs to one of the best. So we have sort of proven that we can do a great job while being compliant. And we are really unparalleled in our openness. Everything we shared, the data that we use is available in a reproducible way. The pipelines that we used are available and the technical report. And you can also see here, to a degree, like the number of people that have been involved. There's been over 100 people involved in this project. So it's quite a collaborative endeavor. And what's also quite fascinating is that the majority of those people are actually PhD students and postdocs, which essentially are volunteers that contributed to the APERTVS project. Now, this is maybe not sustainable for a very large project, and we're increasing our engineering team. As I mentioned, we have a few people already here, but this we plan to grow even more, and we also want to encourage and collaborate with other researchers around the world who are interested with the same mission as we have. And I didn't mention this before, but this is also why we kind of called it APERTVS. This hints a little bit at its European origins, but it's not supposed to be a Swiss model. And that's also why the data distribution that went into the model is essentially more or less a mirroring of the data distribution as it is currently available to us through, for example, common crawl data dumps. So like the data that is represented on the web. Here's an overview of our responsible data practices, which are one of the things that sets us apart from other efforts. We use only data that is publicly available. We categorically refuse data that is illegal, that was uploaded illegally, that violates the copyright intent of the authors. We also respect AI opt-outs. We do this through robots.txt filtering. We do lose some data here, about 8% in English and 4% non-English data, but actually, interestingly, mostly using the news domain, and that doesn't seem to hurt performance as much. We also have methods in place, unprecedented at this scale, to prevent the memorization of this data. And this we show this through using a proper scientific process with control data that we added to the training of the model, which we'll get to in a moment. And here you see a few of a comparison with some of the other efforts. Here's the data distribution we have for the APERTVS 1 model. For the pre-training specifically, about 60% is English, as it is the majority of the data that we have is in English as well. And it's good to have a strong primary language for the training of the model. But 40% is coming from this pie, essentially, which contains a lot of low resource languages as well. Particularly interesting here is also this gives us a unique opportunity to study model capabilities, as we can specifically show what are the sort of documents that have gone into the training of the model, which may or may not explain certain behaviors that the model has in post-training. And we see in the most recent research as well that this information is actually quite critical to better understand how the models have been aligned and what the model's capabilities are, not just the sort of post-training we do afterwards. Here's an example of our memorization experiments we did. On the right here is a control experiment at like the 8 billion scale. The y-axis is repetition, where at the beginning you only use the data once, and at the bottom you use it 128 times, and you check like how good can you generate some of the data that you've trained on. So given the prefix of an existing document that was in the training data, is the generated suffix overlapping with the real suffix? And you can see here by the increase in red that even an 8B model pretty quickly starts to memorize the training data after like 2 dozen repetitions. Whereas here at the 70B scale, where this is actually becomes much more severe the bigger the model is, we have had we've been able to actually successfully prevent this for the control data that we added. And if you want to know more about this, here's Ishwan also in the to speak more about this. This is one of his core efforts as part of his master thesis, and now he's as an engineer with us working on APERTVS 1.5. And so you can see this also is driving not just sort of products and models that we are releasing, but it's also driving a lot of research and education that we're doing, education on the PhD level, but also this sort of experience leads to the education of master students that at EPFL and ETH primarily as well, that is giving us an ability to enhance our capabilities as we move forward and distribute and democratize the lessons that we've learned throughout this. So Hugging Face, APERTVS is available on Hugging Face. You can download the weights there. By the end of the year of 2025, we had about 1.8 million downloads for the 8 and 70B models together, which is quite a lot for a public weight, an open weight model that you can get. It's also available on various cloud providers. This is something that we are focusing much more on. And you can also try it out already on publicai.co. And there's even an API version of this on platform.publicai.co. Once you go to that website, make sure to log in so you have the bigger model, and make sure to also enable the search if there's on the bottom of the text box, so you get like the best sort of experience of how the model behaves in a particular system. And this is from a third party, mainly from Josh, who's also here. Hi, nice that you made it from Geneva. And this is a completely separate initiative, very interesting as well. We'll probably hear more about this later today. I want to briefly then also stop because time is running out. Explain 2 key enablers that make this sort of research possible. On the one, this is ALPS. We'll hear more about this from Joost in the afternoon, I believe. This is really one of the largest, especially European infrastructures we have that is really AI ready. There's over about 11,000 NVIDIA GPUs. We've trained on about 4,000 of those. So you see there is still a bit of capacity to go larger, and this is what we are planning to do. But it's not just about the hardware having it available. It's actually also quite challenging to then make sure that the entire software stack is running smoothly, so you get the sort of throughput that we need to train efficiently versus, for example, the image on the top, which was before we did some significant stability improvements. Another key enabler is the Swiss AI initiative. So for those who are not familiar with it, the APERTVS project is essentially one of many research projects of the Swiss AI initiative. And the Swiss AI initiative has a steering committee, which is distributing the resources as well. These are opened to through these open calls, small projects with, let's say, up to 50,000 GPU hours, and larger project calls as well, which are here to really foster research, and is currently supporting researchers by a lot of people that are not just at Swiss institutions, but also outside Switzerland, Europe, and beyond. And so you can scan this QR code to get some more information on this. And the initiative as a whole is part of the Swiss National AI Institute. So without explaining it too much, but this also is looking into industry collaborations, and you can see here some of the companies that are currently a partner in this as they are funding research, but also are interested in using this technology for their own need. And to close, we are currently working on APERTVS 1.5. This is a model we're going to be releasing soon. The idea is to do so by the late spring. This is a continued pre-training of our existing model. One of the main 2 priorities that we have is also based on the feedback we've got from the community, which is image inputs and audio inputs. So the model is going to be multimodal, and an improved post-training to improve its instruction following capability as well as agentic capabilities more general. And we have been making great progress towards that. In particular, when it comes to image capabilities, we have an approach that is doesn't have like a vision backbone, but is actually more native, which we're quite excited about. And come talk to us if you're interested. And so with this, I'm closing. Thank you so much. And we're always available on this email for potential collaborations and interest. So do get in touch. And we are here all day, so we can discuss further. Thank you so much.
We have time for one question, Genial.
Okay, so I mean, you are advertising the full transparency, and I mean, one have to clearly state here that the dataset side in APERTVS is not covered transparently, right? So there is no dataset that is ready to be downloaded from Hugging Face or any other. So if you look at available data like DCLM, FineWeb, Nemotron CC, it's there. It was preceding even APERTVS, so it's possible to do it. And the pipelines that are there for reproducing, I don't think there is anybody else who managed to actually combine the APERTVS data together except the APERTVS. So I think here you have to clearly take a stance that this is still missing, right?
So what we did is we don't share the data ourselves. There are some difficulties in that, as we are not the copyright owner of this data. But we are using data that is publicly available, and we have certain standards to this data. So it needs to be publicly available, it needs to be versioned in some way, and it needs to have a license that allows us to use it. And right now we are limiting ourselves to licenses that allow commercial use. And within our the pipelines and the things that we shared, it essentially explains what are the different data sets that we use that we bring together. So a lot of the data that we have used for APERTVS 1 is exactly these sort of data sets that you mentioned, like DCLM, FineWeb, and others. And it's about how this comes together. Now, we did share the pipelines that we used for processing this further and how to filter these. But I do agree it's a bit of a challenge to make sure this is really fully reproducible by others, and we're doing our best right now to improve that situation.
The challenge. I mean, this
So we can continue the discussion over.
I'll be happy to get into the weeds of your.
Maybe this is the important bit to know for everyone. What is the challenge?
Yes.
And how to overcome it.
The challenge are these copyright
Well,
questions.
there are open data sets out there from other organizations. How do they deal with those copyrights?
So we can discuss this
I think
further.
that's a legal discussion that unfortunately, particularly in Europe, we keep putting stones in our way.
Well, maybe this
in
is
many different countries.
Hell, yes.
And maybe we should all move to Japan.
Well, maybe we should release it like others did, right? I mean, there are.
Well, other.
On this traveling note, which is very fascinating
debate.
Like this is one of the points to debate later, but we thanks like Imanol for the very interesting